1.14 function model construction and application day 2. We have a situation here where we have data comparing the age in weeks and the weight in kilograms of 5 randomly selected babies from a particular pediatrician's office that are listed in the table above. We are going to do a linear regression. They say a linear regression can be used to model this data. So what you are going to do is, again, a linear regression. So you're going to enter this data into your calculator. You're going to write a linear regression equation, write the equation of the linear model. This time we are doing the other linear regression, the a plus bx. So go ahead and get your linear equation. You can actually do part A and B. So you're going to do, find out what your equation is, and then plug in 10 weeks old. So we're going to be predicting when, what is our age, or what is the weight at 10 weeks, based on the data that we have. All right, so go ahead and take a few minutes. Do that on your calculator, please. All right, let's double check our work. I'm going to go ahead and enter my data in, and we'll check what we have. All right, let's see if I get the same thing as you guys. Okay, I'm going to go ahead and store this, alpha y1. We're going to be using it, so let's go ahead and do that. All right, is this what you guys got? Y equals 3.545 plus 0.185x? Perfect. All right, so part B, we are using our model to predict. Now, we have to pay attention to what they give us. Here, this is that it is 10 weeks old. Well, weeks, is this our x value or our y value? The age. Which one is it? The x, right? Our independent variable. That is our t. TWT. T is the age in weeks. So they're giving us that, that age. So technically, I guess right here, we should write this. So this is what we would write, but we can actually write this as W of t equals 3.545 plus 0.185t. Using the variables that we are given probably would be more accurate. So instead of y of 10, I would actually want to do w of 10 because I'm plugging that in. But that I'm plugging it in because that is an age value. It is 10 weeks. T equals that. So we are going to be plugging it in to our equation. Now, I can type it out just like I wrote it. But since we stored it, we can go ahead and just do that. So I've stored it, so I can go ahead and just do alpha trace y1 of 10. And is that the value that you got? So 5.395. What is our units, though? What's our units of measure? What is that? What is that? Kilograms, right? That is the weight in kilograms. So kg. All right. So let's go ahead and look at problem C. So problem C says the weight of a 6th baby is 5.3 kilograms. Use the model from part A. What is the age in weeks of this baby? So what are they giving us? What are we given? We are given the weight. So can I plug 5.3 in? No, because it is not time, that is a weight. So we are told that W of t equals 5.3, and we want to know what is the time when that happens. So all we have to do is set our equation equal to our value. There was a few problems like that that you may have come across on the Delta math. You have to pay attention. What were you given? Were you given an input value or were you given an output value? In this case, that is an output value. So we have to set it equal. Can we solve that though? Yeah, it's not that bad. What do we do first? just subtract our constant, right? So minus 3.545 on both sides. We have our calculator there, so we can just do it there. All right, so 5.3 minus 3.545. So I get 0.185t equals 1.755. Then what's the last thing that we need to do to find the age of the baby? Divide by? Yep. And so our age, so I take that value and divide it by 0.185. And I get my age is 9.486 weeks. Don't forget your units. Our units in this case for time is in weeks. All right, and that is problem number 1. Go ahead and just double check that you have each of those things. And let me know if you have any questions. Okay, let's go ahead and look at our next thing. We are going to be talking about what are called residuals. Now, a residual is talking about the difference between an actual value and a predicted value. So when we use a model to predict values, we expect our model to be reasonably close to the actual values, but our models are not expected to result in exact values generally. The difference between the actual value and the predicted value is called a residual. Let me help you visualize this. So on our calculator, we can plot our residuals, or plot our scatter plot, actually. We can plot our residuals. I'll show you that another time. But so we have our table. Let's go back to problem number 1. We have our table up here. We entered it into our calculator. I can graph that data. And to do so on the TI, I want to select stat plot, which is above the y equals. So I go second, y equals, and I go ahead and I select one of these. In this case, I'm just going to do plot 1. So plot 1, I go ahead and hit enter. I want to make sure it's on. Mine is. If it was off, I'd go over and select on. This one, the type, I just leave like that. And then the X list, we want to be list 1. The Y list, we want to be list 2. And if all that's there, it will graph my, my scatter plot. Now, I also, in my Y1, I have my linear equation from that I calculated, my regression model. My plot 1 is highlighted, meaning that it's on, and I can go ahead and graph this. Now, if you just had the normal graph, you can kind of see your data, but it might not show all your data. So instead, if we click zoom, number 9, zoom stat, it will graph our scatter plot, our data, and our line, our regression model, our linear model, going through it. So, if we look at our regression model. All right, so looking at this scatter plot in our regression model, when we talk about our residuals, get back there, it's decided to reset itself on me. When we talk about our residuals, this point right here, this is what we call our actual value for that data set at that input. That is our actual value. From our linear regression, we have a point on our graph. That is our predicted value. The difference in between, are they the same value? Are they the same point? No, they're not going to be usually. You can see all our points are not on our model. Our model is a good model. It's pretty close to them, and it runs through and following their path, but normally they're not going to be on the model itself. So the residual is talking about the difference between the actual and the predicted value. That is our residual. All right, so that is what, when we talk about a residual, that is what it is. What is the difference between the two? How close are we to our prediction? Or how close is our prediction to the actual value? What is our residual? Okay? So when we talk about residuals, that's what we can do. For you Casio people, let me go ahead and show you how you can graph your stuff real quick. Let me go back into stat. So it's in your stat menu. So right here, statistics. Let's see, if you go to graph and then graph 1, you get your scatter plot. And then I believe that's right. If you go, when you're in your scatter plot, if you hit calculate and then select your regression, this was a linear regression, the A plus BX, you can then draw your regression model, and so you are able to get the same picture. All right, so a similar setup. All right, so let's talk more about our residuals. So as I said, residuals are the difference between the actual value and the predicted value. So we have an equation here. Residual equals actual value minus the predicted value. I was looking at a video yesterday about this, and the person on the video said you can remember this by remembering the acronym RAP, and they called it their residual RAP. So the residual RAP is our residual equals actual minus predicted. That could be something that you could use. If you want to use it, you don't have to. So that could be something you can use. Residual equals actual minus predicted. It's our RAP, not our RPA. It's the RAP, RAP. Now, some information that the residual gives us. If we have a negative residual, that's going to indicate an over-prediction or an over-estimate. If we have a positive residual, that's going to be an over-predict, or let's see, that one is an under-prediction or underestimate. We're going to be looking at residual graphs a little bit more later, but residual graphs should have no curves, no patterns, and should be evenly distributed. We'll do more with residual graphs next unit. I have a little bit in this lesson. I don't know if we're going to get to it, but they should have no curves, no patterns, evenly distributed to be a good model. If it's an appropriate model, there should be no patterns. The absolute value of the residual should be lower to be a better prediction. So if we have a nice low residual, close to 0, that means it's a good prediction. That means the difference is small. And then R squared, this is a variation in the independent or the dependent variable. And if we have an R squared that is 90% or higher, then we have a good model. Now the R squared on most of your calculators is probably not showing up. But if it does, that's what it means. It's showing you how good of a prediction model it is. I believe my Casio is showing that. Let me go back and do this again. So yeah, so on the Casio, you can see it's showing the R squared. And R squared is 0.99. That means we have a very good model. It is very close to our data. If that was lower, like 0.8 or whatever, that would indicate it's okay, but not the best. All right? You can get that on the TIs, but you have to turn on diagnostics. I can show you that at another time. All right, let's go ahead and turn the page to problem number 2, please. All right, so we are going to be calculating a residual here and interpreting what the residual means. So we are looking at a baby that is 5 weeks old. We are going to find its residual and interpret the meaning of the value in this context. So 5 weeks old, that is right here. What is the actual value of the weight? What is our actual value? What is the actual weight for the baby at 5 weeks old, guys? 4.4 kilograms. We are going to use our model found in example 1 to get a predicted value. So back to your calculators, go ahead and plug in 5. So we're going to do W of 5. What is our predicted value from our equation? So back to your calculator, what is our predicted value? So remember, we're plugging 5 into the equation we got in our calculator. So 3.545 plus 0.185 times 5. We're plugging 5 in. So that's in my y1, so alpha trace, y1 of 5. And I got 4.47. Is that what you guys were getting? All right. So residual. How would we calculate the residual? We have an actual value of 4.4 and a residual of 4.47. How do we find our residual? What is our residual? What does our equation say? Remember, we had a residual RAP, R-A-P. The actual value minus the predicted. So I'm going to take my actual value minus my predicted value. So that would be, in this case, 4.4 minus 4.47. All right. What is that? 0.07, positive or negative? Negative. So negative 0.07, that also has a unit of kilograms. So my residual is negative 0.07 kilograms. That is my residual value. Now, what is the interpretation? So going back to the previous page, what did I say about a negative residual? What would that be? An overprediction, which, if we look at those values, that, well, makes sense. I have 4.47, which is bigger than 4.4, so that would definitely be an overprediction. But we can say since the residual, if I can spell right, residual negative 0.07 is less than 0 or negative, then our prediction is an overestimate. Let's go ahead and do problem 3, and then that's probably where we're going to end for today. So problem 3 says, use the model found in example 1, a baby that was 7.5 weeks old had a residual value of negative 0.7. We got negative 0.07 there. So what was the actual value of the baby at 7.5 weeks old? We don't have that data. Our weeks go from 6 to 8. So I don't know that from my table. But since we are given a residual and we have our prediction equation, we can figure that out. And remember, that is our residual equals the actual minus predicted. Well, they gave us a residual of negative 0.7. I don't know what my actual is. That's the unknown. But can we figure out a predicted value at 7.5 weeks? What would I do with 7.5? Plug it into our model, right? So that is going to be our W of 7.5. So go ahead and calculate W of 7.5 and figure out what our actual value is. So you're going to have negative 0.7 equals A minus some value, which we can then add over. And we can find our actual value. All right, so go ahead and do that. Calculate your predicted value at 7.5 and use our residual equation to find our actual value. All right, we're almost out of time, so let's go ahead and double check our values. So check your work with me. I'm going to go ahead and plug this into mine. So I'm plugging in 7.5. So 7.5. And I got 4.9325. Is that what you guys got? All right, what am I going to do with that predicted value now? Add it over. I want to add that over to here. So I have negative 0.7 plus the value that we got. So our actual value should be 4.2325 kilograms.